Thank you very much to ICCMS organizers for providing us the opportunity to present our research work. Before I start, greetings to my session chairs and all the researchers who are present here in this session. So I will be presenting the research work on novel lightweight Portland Pozzolana Cement PPC based stabilized mud composites using crumb rubber and agricultural waste, along with physico-mechanical and thermal performance. So myself, Rajesh Kumar, working as Senior Scientist and Head of Department in Organic Building Materials Division at CSIR Central Building Research Institute, Roorkee, Uttarakhand. So the outline of this work will be, I will be discussing problem statement and significance, objectives, methodology, major findings along with conclusions, scientific and engineering contribution, and along with acknowledgement. So the problem statement of this research work, as we know that big cover technique is the most ordinary and traditional technique which is used in the normal household and in urban and rural area for waterproofing and thermal insulation. But in this technique, there are few disadvantages. Few are listed here. It causes less thermal insulation because the thermal conductivity of brick is about 0.6 to 1 watt per meter Kelvin. It imposes unnecessarily dead load, and of course, as we know that brick acts as water reservoirs. On the other hand, the mud fusca tiles, mud fusca composites act as better thermal insulating materials, which has the properties such as more thermal insulation, lightweight, and more economical. So the objective was, as the existing mud fusca composite require a lot of time, skilled labor, resources, along with there is shrinkage problem also. So to mitigate that, we have developed precast mud composite roof tile and blocks using different kind of waste, that is wheat straw, bagasse, and crumb rubber. And we have also implemented remedial measures to overcome the problem of shrinkage in traditional mud fusca techniques. The objective was, as a brief methodology, we have developed the dimension of 1 feet by 1 feet by 50 mm tile along with masonry block of 400 by 400 to 100 mm masonry block. Density target was 1000 to 1300 kg per meter cube. Modulus of rupture, or you can say the flexural strength should be more than 1.5 MPa, compressive strength should be more than 3.5 MPa, and thermal conductivity, later I will pronunciate it as K value, should be less than 0.30 watt per meter Kelvin. So we have collected the raw materials, primary raw materials such as soil, less cohesive soil, wheat straw, bagasse, rubber tire waste from local area, along with footwear industry waste also I will show in the further slides. And we have prepared after drying, pounding, and through cryogenic grinding for soil, rubber tire waste, bagasse, and footwear industry waste. After preparation, we have determined the physico-mechanical properties of these raw materials, such as crumb rubber. You can see here the properties: volatility, sieving, D micron size, and moisture content. Along with similarly for wheat straw and bagasse, length, diameter, specific weight, moisture content, and water absorption. After that, as the collected soil was less cohesive soil, so we have stabilized by adding PPC in the ranging from 10 to 15%. As per IS 2115 1980, plasticity index PI should be in the range of 10 to 15%. But after experimentation, we have found that we have to add the PPC ranging from 6 to 12%. So different trials we have conducted, and we have concluded that 10% of cement should be added to stabilize the soil to develop mud fusca composites, tiles, and masonry blocks. So you can see the results after addition of the 10% PPC. Liquid limit was 25%, plastic limit was 14%, and the plasticity index PI was 11%, which was more than 10%, which is the desirability limit as per IS code. So preparation of test sample, we have taken basically primarily 5 kind of mixed proportions: ABC and ABCD and GA, that is the addition of different kind of waste with soil. So you can see here in case A, in first case, soil, PPC, and water. In case 2, 3, 4, we have added the PPC along with wheat straw, bagasse, and crumb rubber, and GA. In case 5, we have added wheat straw and crumb rubber ranging from 5, 7.5, 10%, and the addition of crumb rubber was 5, 7.5, and 10%. So you can see here the water binder ratio was optimized using the flow table test, like as given here. Our target for flow value was 30, 100, and 150, and correspondingly, you can see here from the graph, the water binder ratio was achieved for each case. After that, to determine the strength, density, thermal performance, behavior, we have done the casting and curing. So water curing was done after the vibration table casting, and for developing the model house, we have casted a rectangular block, and to develop the tiles, we have also casted the tile of size 1 feet by 1 feet by 50 mm. Now, the result discussion, we have determined the properties such as density, compressive strength, flexural strength, K value, and the graph between the relative humidity, temperature, along with the time. So you can see here the lowest density was observed for GR3, that is replacement of waste material with the soil. So it was because of the bagasse, because bagasse disturbed all the matrix, soil stabilized matrix, and because of that more water was added, because bagasse absorbed more water, and due to which the density was lower side. But when we have done the curing for 7 and 28 days, the compressive strength was nil, because bagasse, due to the sugary content, because it contains sugar, so there was no binding. So the compressive strength at 7 and 28 days was 0. The compressive strength for control is given here as 13.54 and 17.98. However, we have seen the optimum mix was GA, which has compressive strength of 5.86 at 28 days. The major findings, we have compared our mix, that is GA mix, with the normal brick. We have procured the bricks from market, and we have determined the compressive strength, density, and K value. You can see here each and every property was in the suitable and desirable range that is required for normal household application. So as in conclusion, for achieving the desirability requirements that as per IS code, the PPC up to 10% was added, and which was optimized mix. The optimized mix was GA mix, in which wheat straw and crumb rubber was added. Wheat straw was 7.5% of total weight of dry mix, and crumb rubber was 10% of total weight of dry mix. After adding crumb rubber into the soil mix, the K value was in the range, but the density was in higher side. Mix number GA was optimized sample. Of course, we have discussed already, and the same mix proportion was used to make roof mud composite. And you can see here the observed value regarding density, thermal conductivity, and flexural strength, and drying shrinkage. So you can see here the drying shrinkage through which through our optimized mix, in which we have added PPC and some fibers along with the crumb rubber. You can see here the drying shrinkage was within the range. That is, it was 0.073%. So scientific and engineering contribution of the work was the development of engineered lightweight mud composites and tile using industrial agricultural waste. Also, we have proposed the nomograms of different kind of soils. Suppose we have some kind of corrosion-less soil. So how much stabilizer you have to add in terms of cement, PPC cement, and OPC cement, and what should be the water binder ratio, and if it is so, what should be the strength and density along with K value as it should be. So we have given the nomograms, and it is published in the national magazines, in institutional magazine, as well as in CSIR magazine also. So this project was funded by CSIR, and regarding CSIR 800 project. So thank you all with this, and I welcome you all for any kind of queries.